Yeah. So let's see. We were working with the operator. Okay, operators. We were working, and I told you some basic idea. I think. Yeah, this we have completed the nested if. Nested if we have completed in the last class. We completed this one nested. I told you about the nested one inside another. Now, program on logical operator. Yes, program on logical operator. So we have to work with this program on logical operator. You remember, guys? I told you I have created one diagram and I have saved the diagram in my desktop. Logical operator. We have three operators in what logical. Okay, we have three operators in logical operators. Okay, logical operators are used to join or construct a compound statement. Okay, whenever we want to construct or whenever we want to join the statements, we are using what a logical operators. Correct or not? Logical operators just to construct or compound statements, join the statements. Now, compound statement is a combination of several conditions. So whenever we have a compound statement, what we have, sir, we have the conditions, several conditions we can have, several conditions we can compound, several conditions we can join all together. Okay, several conditions we can join what all together. Just look at this program. If you look at this program, earlier one, so we have what this program is a little bit lengthy, sir. Why this program is little bit lengthy? Look here in the line number 12. In the line number we are checking what A is greater B, A is greater than B or not. Okay, A is greater than B. If A is greater than B, if let's suppose A is greater than B, then only it will check A is greater than C or not. And if both the conditions are true, if A is greater than B, true. If A is greater than C, true. Then what? Big is equal to A. Then what? Big equal to, then what? Big is equal to A. I'm not getting. Okay, now is it visible? Yeah, now visible. Okay, so yes, what I told you, this was the last program, guys. This was the last program. Okay, this was the last program we did in the last class. Now, if you observe this program, here we are checking at line number 12, sir. At line number 12, what we are checking? We are checking whether A is greater than B or not. Whether A is greater than B or not. Correct or not? Whether A is greater than B or not. In the next line 14 line, what we are checking, A is greater than C or not. Okay, okay, A is greater than C or not. If A is greater than B, and in this 14 line A is greater than C, then of course we have what, big equal to A. Why? Because we are comparing three numbers. We are comparing three numbers. Which one is the biggest? Okay, which one is the biggest? So A is greater than B, and what, A is greater than C. Okay, so instead of writing in this style, it would be more better. It would be more better if we join both the statements, sir. If we join both the statements, if I write if, look at how can I join. I can write if A is greater than B and A is greater than C. Okay, so this would be more easy. This would be more easy to join all the conditions, all the simple conditions we can join. Look at here, we have a condition. Okay, A is greater than B, and then we have what, and operator, and then what, A is greater than C. Okay, now, when this and condition will give you true, sir, when this and condition will give you true, when both the conditions are true, when both the conditions are true, correct or not? When both the conditions are true means what? Here, if A is greater than B, true, and if A is also greater than C, true, then only you can write what? You can write big is equal to A. Then only you can write what? Big is equal to A. Okay, so this is the benefit of what? This is the benefit of these kinds of operators, sir. This is the benefit. Okay, otherwise the program will become lengthy. Otherwise the program will become what? Lengthy. If we use logical operator, what will happen? In a single line we can combine several statements. In a single line we can combine several conditions. That is the benefit. Okay, so I hope you have already taken the screenshot of this one. Come on, tell me. If you have already taken, fine. If you have not taken, you can take this screenshot. Logical operators, sir. Okay, logical operators. So I told you logical operators are used to join or construct a compound statement. You can join or you can construct a compound statement altogether. Okay, a compound statement is a combination of several conditions. We have three types of logical operators, sir. The first one is what? And operator. I had given you one exam, one example on examination system. I had given you one example for examination system. Okay, first they failed, no need to appear in the all other examination. Okay, so and operator, if first condition is false, no need to check all the conditions. Why? Because in and operator, all the conditions must be true. All the conditions must be true. And let's say here, if you have, let's say, if A is greater than B, A is greater than C, and let's say A is greater than B. Okay, if we are comparing four numbers, if you're comparing four numbers, okay, A is greater than B and A is greater than C and A is greater than D. Assume that we are comparing four numbers for biggest. Okay, now if the first condition is false, A is greater than B, false. Why? Because the B value is greater than A. Okay, you need not to check this one and you need not to check this one. Okay, right? If the first condition is false, that means what? The condition is false only. The if condition will return false only. If your first statement is false, first statement is false, then this if condition will return false only. No need to check this A is greater than C and A is greater than D. Why? Because what is the condition of and operator? The condition of and operator is what? All the conditions must be true. All the conditions what? Must be true. Look at here, all the conditions must be true, then only the and will return true. But what about or, sir? Or at least one must be true. So if it is or operator, sir, if it is instead of and, if we have or operator, if we have or operator, then we will check at least one must be true. If A is greater than B, fine. If A is greater than C, at least fine. Otherwise, if A is greater than D, at least, then it is fine. Okay, so or operator, at least one condition must be true. Okay, at least one condition must be true. Now, what is nor operator? Not operator, it is just like inverter. Okay, if it is true, it will make it false. If it is false, it will make it true. Okay, it is an inverter, sir. It is an inverter. It will make true and false, or false and true. Okay, simply it is an inverter. Now listen, so if we go to the programming part, we have already completed this one. Now go to the test 23. Look at, yes, now the same program we can write by using logical operator. The same program, look at program on logical operator and or not operator. Class what? Test 23. Class test 23, public static void main string of arguments. Int A is equal to 12, int B is equal to 15, int C is equal to 13. Okay, definitely B is what? Biggest. B is biggest we have. Int B is equal to 0. Now what I can do, sir, look at how short it is. How short it is. If A is greater than B and A is greater than C. Okay, if A is greater than B and A is greater than C, big is equal to what? Big is equal to what? Big is equal to A, correct or not? If A is greater than B and A is greater than C, then big is equal to what, sir? Big is equal to A only. Now, if B is greater than A and B is greater than C, then big equal to B. And if both the conditions are false, if A is not big, if B is also not big, then of course, definitely big is equal to what? C. The big number is what? Big. Correct or not? Only 3 to 4 lines we can find out the output, sir. Okay, but if it is in the nested loop, if it is in the nested loop, what is the problem we are facing? What is the problem we are facing? We need to write what? Multiple if conditions for inner loop and outer loop as well. Okay, here we can compound what? Multiple conditions we can compound, multiple conditions we can join. Okay, fine. So look, let's see what is happening in this program, sir. What is the value of A? The value of A is what? 12. 12 is greater than 15. 12 is greater than 15. Condition false. Condition false means you need not to check this one. Okay, come here. B is greater than A. 15 is greater than A. 15 is greater than 12. Yes, condition true. 15 is greater than A. Yes, A, condition true. Okay, now we will check. Okay, B, that is 15 is greater than C, 13. Yes, condition true. That means what? Big is equal to big, and then it will what? It will print the big number is big. That is what? 15. Okay, no need to go this else part. So when you compile and run this program, look at, so go to the D drive, CD Java, CD introduction, CLS, CD operator, CLS, Java seed test 23 Java. Java test 23. Okay. So the big number is what, sir? 15. Okay, correct or not? The big number is 15. You can take the screenshot of this program. This is on what logical operator, sir. Okay, up to line number 12. You take the screenshot up to line number 12. Now. Okay, done. Now, this one. Concise code, sir. Okay, the code is concise. Why the code is concise? Due to compound statement we have, due to logical operator we have. So we can easily join. Okay, we can easily join. Okay, fine. Now moving to the next program, sir. What is the next program? Just look at. Sir, the next program on OR operator, sir. Look at OR operator. Class test 24, public static void main string of arguments. Int A is equal to 10, int B is equal to 5, int C is equal to what, sir? 20. Okay. A is equal to 10, B is equal to 5, C is equal to 20. What you are writing here, A is greater than B. A is greater than B. 10 is greater than 5. 10 is greater than 5, correct or not? Look at A is greater than B. 10 is greater than 5. One condition is true, sir. At least one condition must true. No need to check this one. Okay, this will return what? This will return true. The first will return true. Okay, the first will return true. Now, second, B is greater than C. B is greater than C. 5 is greater than 20. Condition false. A is greater than C. A is greater than C. 10 is greater than C. Look at 10 is greater than C. Condition false. What is the value of B? 5. 5 is greater than 20. Condition false. Okay, 10 is greater than 20. Condition false. Both the conditions false means what? It will return what? False. So first will return true, the next will return what? False. At least one must be true. Yeah, true and what? False. Okay, take this screenshot. At least one must be true while working with OR operator. Take the screenshot. These are the simple programs we have, sir. Okay, simple programs on logical operator. Okay, and or. Now we will work with not operator. Try to listen. Okay, moving to the next program, sir. Okay, not operator. Not operator works like an what? Inverter. Okay, just to invert, just to convert. Okay, let's see here. Sir, class test 25, public static void main string of arguments. Okay, string str1 is equal to hello. Okay, hello. String str2 is equal to what? Hi. Okay, now str1 dot equals, look at carefully, sir, don't confuse. Str1 dot equals str2. What equals method checks, sir? It checks the content, correct or not? It checks the content. So what it will return? It will return false, correct or not? What it will return, sir? It will return false. Okay, what it will return? False. Why? Because the content of both the strings are not same. The contents of both the strings are not same, correct or not? So it will return false. Now it will return false, and now due to this not operator, it will convert this false to true. It will convert this false to true, correct or not? It will convert this false to true, and once it is true, the if condition will become true, and you will get the output system dot out dot println both are not equal. Both are not equal, correct or not? Both are not equal. Don't confuse with the program. Just look at carefully. Sir, STR1 and STR2 both are not equal, sir. Both are not equal in content. Okay, both are not equal in content. So of course, this equals method, what it will return, sir? It will return false only, false only. Okay, false only. But due to make this if condition true, I want to make this if condition true. I have put it what, sir? Inverter, not operator, not operator. So it will make this false as a true. This will make as a false as a true. So if condition will become true and you will get output, both are not equal. Now let's run this program. 25 dot Java test 25. Okay, so what you are getting, both are not equal. How this both are not equal coming, sir, due to this if condition becomes true, correct? Or how this if condition is becoming true? Why? Because equals method is returning false or not? Yes, equals method is returning false. Why it is returning false, sir? Of course, sir, both the contents are not same, but due to this not operator, this if condition will become true. Okay, so please take the screenshot of this program as well. Take the screenshot. I hope it's clear. Okay. Okay, sir. Moving to the next. Just look at, sir, Boolean operators, sir. Okay, Boolean operators. Listen. Now, next category is what? Boolean operators. Same, sir. Boolean operators. Boolean operators. Sir, these operators, these operators will work with, will work with the Boolean variable. Will work with what, sir? Boolean variables. Boolean variables and produces Boolean type result. And produces Boolean type results. Okay. These operators will work with what, sir? Remember only 2 points. These operators will work with Boolean variables, sir, and they are what, sir? They will return Boolean types of result. Okay. We have three types of Boolean operators. We have three types of Boolean operators. Boolean operators. We have three types of Boolean operators. It's quite simple, sir. What is the first one? The first one is and Boolean operator. Look at this one, sir. Only single. It is what, sir? And Boolean operator. And Boolean operator. Correct or not? And Boolean operator. Now, this one is what, sir? Or Boolean operator. Or Boolean operator. And it is a little bit confusing, sir. Not Boolean operator. Okay, not a Boolean operator. Why? Because it is same with a logical operator. Not a Boolean operator. Okay, in these cases, what we have a single symbol. In these cases, what we have single symbol. What about and operator? This one is and operator, sir. But this is what and Boolean operator. This is what logical or operator. Logical or operator. But this is what, sir? Or Boolean operator. But it is what both are same. Not operator, both are same. Okay, so you have to check whether it is applicable on what, on Boolean variables or not. Okay. Now, please take the screenshot. Please take the screenshot. And I'm not writing, sir, the same thing. What is same? And operator, the same behavior. And operator, the behavior is same, sir. Okay, if all the conditions are true, then only it will return true. And operator, or same if at least one must be true. Not okay, it is just inverter. Okay, it is just inverter, exclamatory symbol, it is just inverter. Okay, so I hope it's clear. Are you getting my point, all of you? Just write in the chat window. Can you easily find out the difference between logical operators and Boolean operators, sir? Logical operators and Boolean work is same, sir. Whatever we have logical operator, the same thing we have in Boolean operator. Okay, only we have what, single symbol. But in case of not operator, you have to very careful whether the values are with value Boolean variables or not. Whether the operands are Boolean variables or not. Now let's see. It's same, sir. It's same. So no need to check. This is same. Same as what? Same as logical operator. So look at this 26. As I told you, what are those, sir? As I written, and what? Boolean and operator, Boolean or operator, Boolean not operator. Boolean not operator, same. Logical operator and Boolean not operator, same. Boolean operators and Boolean. Okay, same thing we have written. Now come here. Look at carefully. Class test 26. Public static void main string of argument system dot out dot println true and true. Both are true. So what it will return? It will return true. Okay, true and true. Both are true. That's why it will return what, sir? True only. It will return true. System dot out dot println true and true. Okay, look at logical. Okay, this will also return what, sir? True. True, correct. This will also return true. Now, system.out.println true or false. At least one condition must be true. At least one condition must be true. So what it will return, sir? It will return true because one, at least one must be true. Now, logical or both are true. It will also return what, true. So all the conditions you will get what, sir? True. Test 26. True, 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 true. Okay, please take the screenshot. True, 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 true. Okay. And not operator behavior is same, just like inverter. Okay, now moving to the next, sir. Okay, moving to the next, sir. Next we have, sir, bitwise operator, sir. Bitwise operator, look at it, is very popular, sir. Bitwise operator, I've seen most of the students. Okay, bitwise operator, what is bitwise operator? Sir, in bitwise we have three operators, sir. In bitwise we have what, three operators. Okay, look at bitwise we have three operators. What are those, sir? First, we have what, same and operator. First, we have what, sir, same and operator, and the work is same, sir. First, we have what, and operator. Okay, and operator. This is and operator, and operator, and the work is same. What is the work, sir? If both argument or all the arguments are true, then it will return true. Okay, all the conditions must be true. All the conditions must be true. Same. All the conditions must be true. Correct or not? Yes, all the conditions must be true. Same. Now, next we have, sir, next we have OR operator. OR operator. This is also same to same. Okay. OR operator. OR operator. What is that, sir? At least one condition must be true. At least one condition must be true. Must be true. At least one condition must be true, sir. Now here we have something, some new operator. Look at what is that, sir? This operator, cap symbol. This is called cap. Okay, cap. Okay. Now what it is called, sir? It is called XOR operator, sir. It is called what, sir? XOR operator. XOR operator. XOR operator. Okay, XOR operator. XOR operator. What is in XOR operator, sir? Sir, arguments must be different to each other, then it will return true. Okay, arguments must be different to each other. Or let's say, if both the arguments, if both the arguments are different, both the arguments are different. That only you have to remember. If both the arguments are what, sir, different. If both the arguments are what, different, then it will return what, true. Then it will return what, true. Then it will return true. That only you have to remember. Then it will return true. Return true. Then it will return true. If both the arguments are what, are different, then only it will return true. Okay, so better to take the screenshot. And operator, or operator, XOR operator. and operator, or operator, and what? XOR operator. And operator, all the conditions must be true. Or operator, at least one condition must be true. XOR operator, if both the arguments are different to each other, then it will return true. Okay. Now listen. In order to learn this bitwise operator on okay, in order to learn this bitwise operator, what we need to do, sir, we need to have some idea of logic gates, sir. We have. Please take the screenshot. We have some idea of logic gates. Sir, what is logic gates? Try to understand. I hope you have the idea of logic gates, but I'm just giving you one recap of logic gates. Okay. What is logic gates? Sir, try to understand. Sir, first, actually, we have to learn only three. And, or, and what? XOR. So, no need to learn all the logic gates. Okay. Let's say AND gate. What is AND gate, sir? AND gate. You know how we will create AND gate? Very simple, sir. Listen. Okay, I'm just making some rough diagrams, sir. Okay, this is the symbol of AND gate. This is the symbol of what, sir? AND gate, AND gate. Okay, and let's assume that if A and B are two inputs, sir, A and B are two inputs. A and B are what? Two inputs, and let's say F as the output. F as the output. Okay, what it will give you, sir? It will give you A dot B. And operator, sorry, A dot B. AND gate means what, sir? Okay, and get means what? We represent this what? We represent with dot. Okay, we represent with what, sir? We represent with dot. And get can be represented with what, sir? Dot. Dot. Okay, and get can be represented with dot. Okay, so what expressions I can write here? Look at what expression I can write here. I can write here F is equal to what? A dot B. F is equal to what? A dot B. This expression we can write here. Now, look at carefully. So here we have two inputs, sir. Here we have two inputs. So there is a formula. The possible number of con Look at what is the formula. The possible number of combination. The possible number of combination for the input. Possible number of combination for the input. The possible number of combination for the input. Sir, what is the possible number of combination for the input formula is, sir? The formula is actually what? 2 to the power n. The formula is what, sir? 2 to the power n. The possible number of combination of input is what? 2 to the power n. This is the formula, sir. 2 to the power n. Where n is what? Where n is the number of inputs, sir. Okay, where n is what, sir? 2 to the power n. Where n is number of inputs. Where n is number of inputs. Where n is number of input. Number of input. Where n is number of input. So look, 2 to the power n, how many inputs we have? 2 to the power n, 2 to the power 2. Correct. How many inputs we have? 2 to the power 2. Right or not? 2 to the power. Actually, we have two inputs, sir. If you have three inputs, then the possible combination is what? 8. But we have what? 2 to the power 2. So is equal to what? 4. Is equal to what? 4. That means what? 4 possible combinations. 4 possible combinations. Possible combination. Four possible combination. Okay, so that totally depends upon what, sir, the number of inputs you are taking. If you have three inputs, then eight possible combinations, but we have only two inputs, A and B, sir. We have only two inputs, A and B, so the possible combination is what? Four. Okay, so what are those four possible combinations? Try to understand. What are those first four possible combinations? So we have two inputs, A and B. And what is the output, sir? The output is F, sir. Okay, output is F. What are the four possible combinations? 0, 0. We can take 0, 0, 0, 1. Okay, 1, 0, 1, 0, sorry, 1, 0. Okay, 1, 0. And finally, what we can take? 1, 1. 1, 1. It's quite simple to find out the expression, sir. It's quite simple to find out the expression. Look at it is what, sir? Dot means what? Multiplication. You just multiply A into B. Okay, A into B. Just multiply, sir. Nothing else. A into B. 0 into 0, 0. 0 into 1. What you will get? 0. Okay, 1 into 0. What you will get? cross, you will get, sir, 0. Sir, 1 into 1, what you will get? 1 into 1 is what, sir? 1. Okay, 1 into 1 is equal to what, sir? 1. Okay, this is the possible number of combination, and this is the output you will get. Okay, remember this output very carefully. It will be useful while making the program, sir. While making the program, this will be useful. One more thing you can tell here. One more thing you can tell here. Look at, this is the inputs we have, sir. This is the inputs we have. Okay, don't write. This is the inputs. A and B are inputs. Okay, A and B are inputs. Don't write. Just draw one, this one. This is the input we have, and this is the output we have. Okay, these are the inputs and these are the outputs. Now, if you observe carefully, sir, if you observe carefully, we are getting 0 in three cases. We are getting 0 in three cases, sir. In three cases, we are getting 0. That means what? Look at how, what you can write, sir. What you can write, if any of the input is 0, look at, if any of the input is 0, the output is 0. Okay, what you can write the another way, you can write, if any of the input is 0, if any of the input, if any of the input is what, sir? 0, 0, 0 is also known as low. Okay, 0, 0, then the output will be, then output will be, output will be what? Low only. Output will be low only. Okay, output will be 0 only. Okay, output will be 0 only, or output will be 0, and in bracket you can write low. Output will be 0, in bracket you can write low. Okay, correct or not? So we have low output, we have low output. Okay, now please take the screenshot. This is what about, sir, AND gate. This is what about AND gate. To work with bitwise operator, you have the idea of AND gate and the respective OR gate and XOR gate. Okay, then only you can easily find out the output, sir. Please take the screenshot. Now, very quickly we will see what. Very quickly we will see the OR gate. Look at what is OR gate, sir. Sir, OR gate is represented by plus. Okay, OR gate is represented by what, sir? Plus operator. Sorry, not plus. This plus symbol, sir. This plus. Okay, OR gate is represented by what, sir? This plus. Okay, this plus. What is the diagram, sir? How we will create the diagram? Okay, look at how we are creating the OR diagram. Again, we have two inputs. This is A, this is B. The diagram would be something like this one. Okay. Yes, this is the diagram. Sir, again we have two inputs, A and B. Correct or not? We have two inputs, A and B. Let's say F is the output. F is the output. What expression we can write? Expression we can write A plus B. A plus B. A or B. A plus B is nothing but A or B. Okay, this is the expression we can write. So here we can write F is equal to what, sir? A or B. A or B. Correct or not? Yes, sir. Now, sir, what are the inputs? Again, we have two inputs or not? So possible number of combination is what? 4 only. 4 only. So what I can write, sir? A, B, and what? F. Okay. No need to take more space. 0, 0, 0, 1, 1, 0, and what? 1, 1. Look at what we have, sir. Plus. Okay, plus. So add, sir. 0 plus 0, 0. 0 plus 1, 1. Okay, 1 plus 0, 1. Okay, 1 plus 0 is what? 1. Now here you have to take a very much care, sir. 1 plus 1, 1 plus 1 means what? 2. 1 plus 1 means what, sir? 2, 2. But in binary we don't have 2, sir. In binary we don't have 2. In binary we have only 0 and 1. Only 0 and 1. So even 1 plus 1 is 2, you will write here what? 1 only. Okay, even 1 plus 1 is 2, you will write 1 only, because in binary we don't have 2, sir. Okay, in binary we don't have 2. And what is the conclusion? What is the conclusion? We are getting what? We are getting 1, 1, 1. So what conclusion you can write? You can write, if any of the input is high, that is 1. If any of the input is high, that is 1, the output will be high. Okay, this is the conclusion you can write. If any of the any of the input is high, sir. Input is high. That is one. Okay, that is what one, or let's say the same style one. That is what high. High. Okay, if any of the input is one, the output is what, sir? The output is one. That is high. Input is high, output will also high. Okay, take this screenshot. Here we are performing addition, sir. Okay, here we are performing addition. 0 plus 0, 0 plus 1, like that. OR gate. Okay, this is what about OR gate. Now, take the screenshot. Now, please look at XOR gate. What we have in XOR gate, sir? Just listen. I hope you have taken the screenshot. Okay. Now, I'm moving, sir. XOR gate. Sir, what XOR gate, sir? Look at XOR gate. It is also called as exclusive OR. Exclusive OR gate. Correct or not? Exclusive OR gate. Exclusive OR. XOR gate. That is what, sir? Exclusive OR. What is the condition in exclusive OR? Both arguments must be different. Okay, both argument must be different. Now, how to create the diagram, sir? How to create the diagram? What is the circuit diagram for exclusive gate? Look at it. It's quite simple. Same like XOR gate, sir. Same like XOR gate. Same like XOR gate. Exclusive OR. This one, this one. Here we have what? This is X. This is what? OR gate. This is OR gate now. Yes. And if you put one more here, this will become XOR. Okay, this will become XOR. Now, what is the symbol of XOR? The symbol of XOR is what? Just like OR, just like OR. Okay, just like OR. A plus B means what? OR. But this plus is what inside a circle. This plus is what, sir? Inside a circle. Okay, this plus is what? Inside a circle. A plus B. Okay, A plus B. Now, that is what A XOR B. A plus B means what? Or A XOR B. It is A XOR B. Two inputs are what? Two inputs are A and B. Two inputs are A and B. Okay, and F is the output. F is the output. Okay, what expressions you can write? Same, sir. A XOR B. A XOR B. Okay, the same expressions we can write here. A XOR B. Okay, A XOR B. Sir, what is the input, sir? No need to write again and again. What is the input? A, B, and what? F. Now, here you have to remember only one thing. Look at here, you have to remember only one very simple thing, sir. If you remember that thing, it would becomes very easy. What you have to remember, sir? Very simple. What you will remember? Same input, output is zero. Okay. What you remember, sir? Very simple. Same input, output is zero. Same input, output is what, sir? Output is zero. That's all. Output is what, sir? Output is zero. Okay, output is zero. Same input, output is zero. That only you have to remember, sir. Look at zero, 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 one, one, zero, one, one. Okay. Same input, output is zero. Here we are getting same input, put zero, and here also we are getting same input, put zero. Okay, zero and zero. Same input, output is zero. And remembering all the places you put one. Okay, that's all. Same input, output is zero. Please take the screenshot. Please take the screenshot so we can move ahead. Okay, so three gates we have: and operator, or operator, and what? Exclusive or, XOR, exclusive or. Okay, now I'm moving to the program, sir. Look at, you can easily find out the output. Okay, you can easily find out the output. Look at system.out.println, true and false, true and false, false, false. Why? Because all the conditions must be what? True only. All the conditions must be what? True only. So it will give you false. Now here, or in or operator, what? True and false. At least one must be true. At least one must be true. It will return true. It will return true. Look at here very carefully. Very carefully, sir. Both the both the inputs or both the arguments must be what? Different. Then only it will return true. Look at true XOR false. True XOR false. So both the arguments are what? Different. Then it will return what, sir? True. It will return true. Both the arguments are different, sir. True, and here what? False. If it is true true or it is false false, then you will get false. But arguments are different, then means it will return what? True. So test 27. Test 27, sir. Java C test 27.java. Yes, now Java test 27. What you are getting? False, true, true. Correct or not? False, true, true. Please write. Please take the screenshot. Please take the screenshot. Okay. Now moving to the next program, sir. Okay. Long. Before this program, you write down one theory. Sir, write down. Just after the program screenshot, you write down. After program number 27, sir. Huh? After program test 27. Sir, what is the point, sir? The point is, sir, we can apply, listen, we can apply bitwise operator. We can apply bitwise operator on integral type, sir. On integral type. Yes, possible, sir. We can apply bitwise operator on integral type. Integral type means, what sir? Byte sort int log. Byte sort interlong. Yes, we can apply bitwise operator what on integral type. That is possible, sir. Okay, let's say how to apply. I'm giving you the output. Try to understand. Look at the first case. What is the first case, sir? Let's say you're writing system.out.println. System.out.println. Listen carefully. System.out.println. What you are writing, let me check what I have written in the program. 6 7 combination. Okay, 6 7 combination. Sir, what I'm writing, sir? 6 and 7. 6 and 7. What its output, sir? What is the output of this 6 and 7? Okay, quite simple, sir. 6 and 7 means what? First of all, you need to find out the binary of 6. First of all, you need to find out the binary of 6. Binary of 6. Okay, I hope you know how to find out the binary of 6. Okay, if you don't know, listen. What is how to find out the binary of 6? Sir, we need to write from like this one: 1 2 4. Okay, 1 2 4. Then we can also write what? 8. 1 2 4 8. And listen, how to find out the binary of any number, sir? Sir, I'm telling you how to find out the binary of any number. Okay, so you have to write the number by in this order, sir. You have to write the number by in this order: 1 2 4 8, 16 32 64, like that it will keep on moving. 1 2 4 8. Now you have to find out binary of 6. So how would you find out binary of 6? What? You have to add the number. Look at what I'm telling. You have to add the number. You have to add the number in such a way. You have to add the number in such a way that the result will be 6. After adding the result will be 6. Result will be 6. After adding the number, the result will be 6. But the condition is by taking the maximum number, sir. By taking the maximum number. So always you have to take the number from right to left. Always you have to take the number from right to left. Okay. So let's see. For 6, can we write? Can we take 8? No, we can't take 8. It is beyond the limit. Can we take 8? No, we can't take 8. It is the beyond the limit, sir. Sir, can we take 4? Yes, yes, we can take 4. So whenever you take the number, okay, whenever you take the number, let's say I'm taking 4. So whenever you will take the number, you write 1. Okay, if you're taking the number, you will write 1. If you're not taking the number, then write 0. Simple. If you're taking the number, write 1. If you're not taking the number, simple 0, sir. So 4 plus 2, 6. 4 plus 2, 6. Yes, sir. I got the result. 4 plus 2, 6. That means I will take this two number. I will take these two numbers, sir. 4 and 2. So 4 and 2 means what? You will write 4 and you will write 1 here. And you have not taken this one. That's why you will write what? 0. You will write what? 0. This is the binary for 6, sir. This is the binary for 6. This is the binary for 6. Okay. This is the binary for 6. Now, what is the binary for 7, sir? What is a binary for 7? Look at by taking the maximum number. So 4, we can't take 8. We can't take 8. Okay, just remove this 8. We can't take 8. So what we have to take, sir? What we need to take? We need to take 4. 4 plus 2, 6. 6 plus 1, 7. That means what? 100% 1, 1, 1. It is what, sir? It is the binary of 7, sir. It is the binary of 7. Correct or not? Yes, it is the binary of 7, sir. Correct. Now you perform what? What you want to perform, sir? You want to perform AND operation. Okay. What you want to perform, sir? You want to perform AND operation. AND operation you want to perform. Okay. You want to perform AND operation. Okay. What you want to perform, sir? You want to perform 6 and 7. What you want to perform 6 and 7. And means what? You remember? And I told you now. And means what, sir? And means dot. And means what, sir? And means dot. Dot means what? Multiplication. And means what, sir? Dot. Dot is nothing but multiplication. Now look at, sir, how would you multiply? Look at, sir, look at this one. Look at this one. 0 and 1. This is the format, sir. Don't confuse. This is the format. Okay, this is the format. Okay, don't confuse. This is the format to check to find out the binary. And this is the number. For 6 we have 110. For 7 we have 111. So 0 into 1. Okay, quite simple, sir. 0 into 1. What? First, look at the first one. What is the first one, sir? 0 into 1. What is the result? Of course, it is 0 or not? 0 into 1, what? 0. 0 into 1, what? 0. Okay. 1 into 1, what you will get? 1. And finally, 1 into 1, what you will get? 1. 1. Okay. So, what you are getting, sir? 110 you are getting. 110 means what you will get? You will get 6 only. What you will get, sir? You will get 6 only. What is the first result you will get? 6. Look at. Look at. So here what you will get, sir? Here you will get 6 only. 6 only. Correct or not? 6. Now, this part is completed. Okay, this part is completed. Now move to the another part. Sir, move to the another part. Guys, are you getting? Are we together? Am I audible? Fine, everything? Just reply me. Are we together? Yeah, fine. That's fine. Just listen carefully. Sir, system.out.println. Now what I have to what is the next one, sir? Sir, the next one is number 2, sir. Number 2, what is the next one, sir? System.out.println 6 or 7. So I'm writing the shortcut system.out.println. System.out.println. Sir, what I want to print, sir? System.out.println 6, 6 or 7, sir. 6 or 7. Okay, 6 or 7. 6 or 7, sir. Okay, so now no need to calculate 6 or 7. You can easily find out what is the value of 6. 1, 1, 0. This is the value of 6, sir, from the last one, sir, here. And what is the value of 7, sir? 1, 1, 1. Okay, so when you calculate, okay, what is, sir? Or means what? Add. Or means what, sir? Add. Correct or not? What is the meaning of or, sir? Or what is the symbol of or? Plus, plus. Okay. What I want, sir? I want 6 plus 7. 6 plus 7. Correct or not? 6 plus 7. 6 or 7. 6 or 7. That is what, sir? That is or. That is or. What is the symbol of or, sir? The symbol of or is what? Plus or not? Yes, the symbol is or, what? Plus. Just you add, very simple, just you add 0 plus 1. What you will get? 1, sir. 0 plus 1 is what? 1 only. 1 plus 1, what you will get? 1 plus 1, 1 only. Okay, in binary, when we don't have 2, 1 plus 1, 1. Again 1 plus 1, what? 1 only. That means 1 1 1 1 1 1 is the binary of 7 or not? Look at 1 1 1 is the binary of 7. So what the next output we will get, sir? The next output we will get 7. 7. Okay, very nice. Now the third one. Third one is again very simple, sir. Third one is again the simplest one. Simplest one. Look at third one. I'm not describing. Okay, 1 1 0. This is for what? 6. And 1 1 1. Okay, this is for what, sir? 7. What we need to find out, sir? 6 6 XOR 7. 6 XOR 7. Sir, 6 XOR 7. Sir, you remember same input output is 0. Same input output is 0, correct or not? Same input output is 0. Okay, where is the same input, sir? Look at, where is the same input? Look at, let me write, where is the same input? Here is the same input, sir. Please wait. Same input output is 0. Okay, so look at same input. Where is the same input? Here is the same input. Output is 0. Here is also same input. Output is 0. Here also different input. 1. Different. 1. Okay. Different 1. You remember, if the inputs are different, it will return true. If the inputs are different, it will return true. 1 means what, sir? True. Okay. Look at false. Oh, sorry. Okay. Wait. So, what, sir? Same input, output is 0. Here, what we have, sir? Here we have 0. Here we have what, sir? 0. 0 means what? False. Okay, it's not taking actually. So, okay, I'm just telling you. 0. 0 means what? False. 0 means false. Again, 0, false. 1 means what? True. 1 means what, sir? True. So you remember what is the condition we have in XOR? The condition is what? If both arguments are different, it will return true. Look at, if both arguments are different, it will return true. So 0 and 1, both arguments are different or not? Yes, both arguments are different. Both arguments are different, it will return true. It is returning true, sir, if both the arguments are different. This is what, sir? This is XOR. Okay. This is what, sir? This is XOR, sir. This is XOR. Correct or not? This is XOR, sir. Okay. So three cases. In this case, what will happen, sir? We will get 1. So in this case, we will get what, sir? 1. So what is the output we should get? The output we should get 671. Test 21, 671 output we should get, sir. Let's see it is happening or not. Oh, sorry, it is 27 only. CLS, it is 28. Now, when you run this one, test 21. Yes, sir. 671. Correct or not? Yes, correct, sir. Okay. So, better to take the screenshot of this one. And I hope it's clear, sir. Okay. I hope it's clear. You can easily find out. But these types of questions no one is asking in the interview, sir. Okay. These type of questions only for the knowledge. Even in the certification exam, you want to find any question from Bitwise operator. Okay, just listen, practice 1 or 2 times, keep your notes, and forget. Don't worry. No one is asking in interview. Even certification examination, we don't have Bitwise operator. Just take the screenshot of this one, and I hope you have the idea. Okay, you have the idea how to work with what, and how to work with or, and how to work with what, sir? Exclusive or operator. Okay, please take the screenshot. Bitwise operator we have, sir. Bitwise operator. Okay, fine. Now take the program. This program, sir. We can apply bitwise operator on integral data type, sir. No problem. We can apply bitwise operator on integral data type. No problem. Okay. Yes, bitwise operator we can apply on integral data type. Okay, completed. Okay, so now I am moving to the next program, sir. What is next? Sir, bitwise complement operator, sir. Okay, bitwise complement operator. It is a big topic, sir. Okay, it is a big topic. Bitwise complement operator test 29. So we will see this on Monday. Okay, we will see this on Monday. Okay, bitwise complement operator. Why? Because it is a big topic. You have to create the full diagram. Okay, you know, in order to find out the output of this four, it's look like it's very simple, but actually you need to learn the ones complement, two's complement. Okay, ones complement of number, how to find out the ones complement of number, then how to find out the two's complement of number. The total story we will learn first, what is ones complement, two's complement, then only we can see what a bitwise complement operator, bitwise complement operator. But was, yes, bitwise complement operator, what is the benefit, sir? It is only applicable on integral literal. Okay, it is only value, it is only applicable with what, sir? With a boolean, with, sorry, with integral. It is not valid for boolean. If you try to compile this program, you will get an error. Okay, bitwise complement operator is only applicable with the integral. With integral test 29, you will get an error at line number 6. Okay, line number 6 you will get error. Test 29. Just 29. Why? Because it is only applicable on what, sir? Integral. Okay. So bad operand type boolean for unary operator. You can't apply bitwise complement operator on what, sir? Boolean. Okay, this is not possible. But yes, if you want to apply on what integral literal, then we have to find out first the first complement of a number, and then the second complement of a number, and then only we can find out the output of this program, what would be the output of this program. Okay, so we will see in the next class, don't worry. Now you tell me, do you have any doubt, any doubt anybody has?